Alright, chào em. Oh, welcome everyone. Today we have a live audience, so it's very, very exciting. So today we're going to learn about adding, subtracting, and conjugates of radicals. So we actually already learned how to simplify radicals, and yesterday you learned how to multiply them and divide them. So today we're going to learn how to add and subtract. And before we start learning how to add and subtract, we actually have to break down the conceptual understanding. If you really understand how to add, subtract, then radical is not really much that different. It's pretty much the same thing. So take a look. Concept-wise, when you're adding something, let's say a 2x plus a 3x, how do you add that? First of all, you just add the coefficients. That becomes a 5x. Do you change the x at all? No, not really. So adding, pretty simple, right? What if this? What if you had a 2x plus 3y? Can you add those together? Not really, because what happened here is that the variables are different, the numbers are different. Therefore, since you can't add them together, you just leave it as that. So that's kind of like the understanding behind that when you're adding. Let's do another problem. What happens if I have 2 times 5 plus 3 times 5? And this is where people start getting confused. How do I add something like that? So, take a look. How do I read this? This means 2 of this plus 3 of this is 5 of the same thing. 2 of this plus 3 more of this means what? That means 5 of that same thing. And when people have numbers there, they think they should add the numbers together, which is not true. This means 25. Take a look. 2 times 5 is 10. Plus 15 is 25. So make sure you don't add those together. It gets really confusing to people. So remember, you add them, these parts stay the same. You're just adding the coefficients. Does that kind of make sense? So thank you. Let's take this back to radicals. Let's look at radicals now. So remember, when you're adding radicals, you want to add the same thing. So look at these. Are these the same radicals? Yeah, they are. So can you add them together? Yes, you can. So take a look. How do you add them? That's 2 of this plus 7 more of this is what? 9 of the same thing. Doesn't change. And people would go, oh, that should be 6. No, it's not. And we just discussed why. When you're adding, you keep it the same. You only add things that are the same. If they're not the same, you can't add them. Over here, take a look at that. Are these the same thing? Are these the same thing? They're not the same thing. That's right. This is a square root. This is a cube root. So can you add these together? No, you can't. So what do? You don't do anything. That's the answer. Yeah, you can't add them. Therefore, that's it. It's not no solution, but you know, that's the solution. That's it. For example, oh, someone. Oh, okay. Take a look. These can't add together. Doesn't mean there's no solution, right? So, by the same token, doesn't mean this is just a solution. Let's look over here. Are these the same? They're both square roots?
No.
They're not, because what? The insides are different. Therefore, can you add these? No, you can't. So good job, guys. So pretty easy, straightforward, right? Over here, are these the same? Can you add them? But hold on. Ah, you got tricked. Yeah. You can simplify. Why don't we simplify first and see if you could add them then? Let's simplify. Let's break down 12 first. Let's break down 12. What goes into 12? 2. 6 left over. What goes into 6? 3 left over. 3 and 1. So I take out what I have in common. First of all, the 4 is still there, correct? I take out what they have. Pairs, because it's square root. A pair of 2's go on the outside times 2. Anything other pairs? What's left over? Square root of 3 minus 6. Let's break down 75 over here on the side. 75. What goes into 75? 25 is too big. Smaller than 25. 2 is odd. 5. Good. Let's do 5. 5 goes into 7 once, leaving 2 left over. 25 is 5. What goes into 15? 3 left over. 3 and 1. Perfect. Take out pairs. You see any pairs? Pairs of 5 with the 3 left over times 5 with the square root of 3 left over. Take a look. What is this? This becomes 8 square root of 3 minus 30 square root of 3. Take a look. Ooh, can you add this? Yeah, you can. Look at that. They are the same. It's just hidden in here. So sometimes you must simplify first and then add them together. Therefore, your final answer, 8 minus 30, is negative 22 square root of 3. And that's how you add and subtract radicals. That's it. Pretty easy, right? Good. So now that we feel comfortable with that, let's talk about conjugates. Take a look. Look at this problem. You've seen these type of problems before. This is a little bit harder, so I didn't start you off easy this time. So how do you break this? What's the problem with this problem? That's right. There's radicals at the bottom. Well, how do I get rid of radicals? Multiply by what? Multiply by the conjugate. Remember, conjugates get rid of radicals. Conjugates get rid of imaginary numbers. Conjugates get rid of radicals. So if you multiply by the conjugate, it will go away, right? It gets rid of square roots, gets rid of imaginary numbers. So take a look. Look at the denominator. What do you think the conjugate is? What is conjugate? Conjugate means the same but different. What? The same but different. Same, how are they same? Same numbers, everything different. How are they different? The sign. Which one? The middle one. So this is square root of 5 plus 3 square root of 2. Top and bottom. Square root of 5 plus 3 square root of 2. Would that really get rid of all the radicals? It's kind of like unbelievable looking at right here. So take a look. Let's distribute them and see. Top. Distribute. Here to here, that becomes, remember when you multiply outside with outside, inside with inside, 3 square root of 5. Outside with outside, inside with inside, nothing inside. Over here, distribute. Plus 9 square root of 2. Next one, distribute. That's going to be negative square root of 10. And lastly, this one right here will be negative 3 square root of 4. Very good. That's the top. Let's simplify the top before we go to the bottom. That becomes, this doesn't simplify, this doesn't simplify, this doesn't simplify, but this does. What does that become? 3 times 2, which is negative 6. So this is going to be negative 6. Simplifies to negative 6. It becomes plus 3 square root of 5 plus 9 square root of 2 minus square root of 10. That's the top. All right, let's look at the bottom. Distribute. First, this to this. Square root of 25. This to this. Positive 3 square root of 10. Oh man, doesn't look too promising. Next one. What's this times this? Negative 3 square root of 10. And finally, this times this. Okay, let's hope everything simplifies. Does anything simplify? Take a look. Luckily, look at this. The middles go away. They're exactly the same, but opposite sign. Can we simplify square root of 25? What's the square root of 25? 5. Very good. The top stays the same. Negative 6 plus 3 square root of 5 plus 9 square root of 2 minus square root of 10. The bottom is 5. And what is this? Negative 9 times 2. Isn't this negative 9 times 2? Negative 18. Take a look. Negative 5 minus negative 18 is negative 6. 3 square root of 5. I'm just rewriting the top. And then the bottom is just negative 13. Take a look. Is there radicals at the bottom? No. So when you multiply by the conjugates, the radicals went away and you simplified the denominators. And there's your answer. It looks kind of ugly, but that's what your answer looks like. How do you feel? That's simplifying radicals. Awesome, guys. All right. We're going to practice more in class, but you basically have the idea. First of all, adding, subtracting only if they're the same. And then if you want to get rid of the denominator with more than one term, then you multiply by the conjugate. If it's just one term, then we did what we did yesterday. All right. Good. That's it. Have a great day.
Wait, give me a shout out, Mr. Hi.
All right. See you guys tomorrow.